Exercise 5.1, question number 10. Find all points of discontinuity of f, where f is defined by fx equal to x plus 1 when x is greater than equal to 1 is equal to x square plus 1 when x is less than 1. Okay, so there will be three cases. Case 1 when x is greater than 1. Case 2 when x is equal to 1. And case 3 when x is less than 1. Just see the point where this here it is 1. So at point 1, at point greater than 1 and at point less than 1. Okay. So case 1 when x is greater than 1, what is the function? X plus 1. Let x is equal to a, where a is greater than 1. Okay. So f of a will be what? A plus 1. When x is a, in left hand side we are putting in place of x a, so in right hand side also we'll put what in place of x a, so a plus 1, give it 1. Now I'll find out left hand limit. What is left hand limit? Limit x tends to a minus fx. What is fx here? X plus 1. Now when we apply the limit, what you'll get? A plus 1, give it result number 2. Now you find out right hand limit. Limit x tends to a plus fx. Fx here is what? X plus 1. So when we apply the limit, what will get? A plus 1. Limit of x is a when x tends to a, and limit of constant is constant. Give it 3. From 1, 2 and 3, from 1, 2 and 3, what you observed? Left hand limit is equal to right hand limit is equal to value of the function. So therefore function is continuous. Function is continuous at x equals to a, where x is or a is greater than 1, that is x is greater than 1. Okay, now next case number 2 when x equals to 1. When x equals to 1, fx is equal to how much? X plus 1. When x equals to 1, fx is x plus 1. Okay, now I'll find out f of 1. F of 1 is equal to 1 plus 1, give it result number, that is equal to 2. That is equal to 2, give it result number 1. Now we find out RHL, right hand limit. Limit x tends to 1 plus. X tends to 1 plus means x is greater than 1. When x is greater than 1, what is the function? X plus 1. That is equal to, now apply the limit. Limit of x when x tends to 1 is 1, plus limit of constant is constant 1. 1 plus 1, 2, give it result number 2. Now you find out LHL. Limit x tends to 1 minus. When x is less than 1, what is the function? X square plus 1. Okay, apply the limit of x square when x tends to 1 minus or 1. Limit x 1 minus means less than 1, but when we apply the limit we put what? X equals to 1. So 1 square plus 1, that is equal to 1 plus 1, that is equal to 2. Give it as number 3. From 1, 2 and 3, what you observed? LHL is equal to RHL is equal to value of the function. What is value of function here? F of 1. So therefore function is continuous at x equals to 1. Now case 3 when x is less than 1, what is the function? Fx is equal to x square plus 1. Okay, so let x equals to a, where a is less than 1. X equals to where a is less than 1. Okay, so f of a will be what in this case? In left hand side, in place of x we are putting a. So in right hand side also you have to put a. So a square plus 1. Give it result number 1. Now you find out LHL, that is left hand limit. Limit x tends to a minus fx. Fx means here what? X square plus 1. So apply the limit a square plus 1. Give it result number 2. You find out RHL, that is what? Limit x tends to a plus fx. Fx here is what? X square plus 1. Now apply the limit. In place of x you put a. So a square plus limit of constant is constant. Gives result number 3. So therefore here what you observed here? LHL is equal to RHL is equal to value of the function f of a. So therefore function is continuous at x equals to a, where a is less than 1. That is x is less than 1. So here what you observe? Function is continuous for x is greater than equal to 1 also. Function is continuous at x equals to 1 also, and function is continuous at less than 1 also. So therefore function is continuous everywhere, means no point of discontinuity. No point of discontinuity.